Hi, Mr. Green here. I'm going to take you through the topic of mechanical power, which is part of the physics energy topic. Our learning objective is to know how to calculate mechanical power using the work done formula. Please pause the video while you take that down as your title. Okay, we'll start as we always do with some retrieval questions. You've got 4 of them on there. Please pause the video whilst you attempt those questions. Okay then, so question 1. What is work? Work is energy transferred when an object is moved a distance. So in science, physics, we'd always say that work done is equal to energy transferred. And generally when an object's moved a distance, we'd refer to that as work done. What's the unit of work? Well, work is energy transferred, so that would be joules. What's the equation to calculate the amount of work done? Well, we've said it's energy transferred when an object is moved a distance. What do we have to apply to an object to move it? We'd have to apply a force. The more force we apply, the more energy we get. The bigger the distance it travels, the more energy we'd need. So work done is equal to force times distance moved. Finally, question 4. What's the equation to calculate elastic potential energy? That would be elastic potential energy is half times the spring constant of the spring multiplied by the extension of the spring squared. Okay, if we haven't got that info, there is a video on elastic potential energy that you can review on our channel. Okay, our learning outcomes today are first off to calculate power, and then to rearrange the power equation to calculate different values. So work done. Let's have a look at some calculations first, make sure we can do this. So we need to be able to calculate energy transferred, or work as we will call it. Now we looked at this last lesson, but to make sure we can do this, we're going to attempt the following questions with this formula. This is the work done formula. Work done is force times distance. So with that in mind, can you attempt those 5 questions? Please pause the video whilst you attempt them. Okay, so question 1, let's go through it. Keon lifts a parcel weighing 5 newtons from the ground onto a shelf 2 meters high. How much work does he do? Well, work done is force times distance, so work done is 5, which is the force, times 2, which is the distance, giving us 10 joules. Question 2, Daff exerts a force of 5.5 newtons to slide his guitar across the table, and he does 2.7 joules of work in the process. How far is the guitar moved? We need to rearrange the equation for this one. If work done equals force times distance, to get distance on its own, we'd need to move force onto the other side of the equation. If it's times on one side, it's divided by on the other side. So distance would be work done divided by force. Work done in this case is 2.7, force is 4.5, so 2.7 divided by 4.5 gives us 0.6. Question 3, Griff uses his beard to pull a car up a hill. He does 405 joules of work on the car. He walks 15 metres up the hill. How large of a force must he exert? We need to rearrange the equation again to make force the subject. So if work done is force times distance, distance needs to go on the other side of the equation. If it's times by on one side, it will be divided on the other. So work done over distance gives us force. 405 joules is the work done. Distance is 15, which gives him a force of 27 newtons. Question 4. How much work is done if a Lamborghini if a force of 3,150 newtons is exerted to move it 75.5 metres. Work done is force times distance, so that's 3,150 times 75.5, giving us 237,825 joules. And finally, Bump has broken his leg and is being lifted into an ambulance. If he's moved with a 2,470 newton force and 3,650 joules of work is done, how far is he being lifted? Again, we rearrange our equation. That's work done divided by force gives us distance, so that would be 1.48 metres. Again, pause the video, make sure you've got all those steps and you've done that correctly. Okay, mechanical power. I've got 2 cars there. Which of these has got the most power and why? Pause the video and write down what you think. Okay, it's this car that has the most power out of those 2. Because power is the rate of transfer of energy, or the rate of doing work. The quicker a machine transfers energy, the more powerful the machine is. So it's not how much energy it transfers in total, it's how quickly it transfers the energy it does. So if it can transfer energy really quickly, it's really powerful. If it transfers energy very slowly, it's not very powerful. More powerful engines can work a lot quicker than less powerful ones. So they usually travel a lot faster, but in order to supply that energy at that rate, they need more fuel to do that. Here's the equation for calculating power. Pause the video whilst you take that down. Okay, so power is work done, or energy transferred, divided by time taken. Work done is in joules, and time is always in seconds. If we're given the time in anything other than seconds, we have to convert it to that. So joules divided by seconds would normally give us joules per second as a unit. But power has been named after a famous scientist called James Watt. So the unit of power is the watt, or watts, capital W. There's our equation triangle. You might want to copy that down if you find that more useful to rearrange equations. Okay, so quick example, I'll take you through this. A car transfers 10,000 joules of energy in 25 seconds. What is its power? So we know power is work done divided by time taken. When I'm doing these questions and I'm working out these calculations, I always do it this way. I always write my equation out first, substitute my figures in, work out the answer, and then put my units in. So in this case, work done is 10,000 and time is 25 seconds. Well, 10,000 divided by 25 gives me 400. I've worked out the power, so that's watts. Final answer, 400 watts. Question 2. A crane lifts a load weighing 3,000 newtons through a height of 5 metres in 10 seconds. What's the power of the crane? Well, first off, I need to know how much work's been done. Fortunately, I know that work done is force times distance. So in this case, the force is 3,000, the distance is 5. So that would 3,000 times 5, work done is 15,000 joules. Now I need to work out the power. Power's work done over time taken. Work done was 15,000. Time taken is 10 seconds. So 15,000 divided by 10 give me an answer of 1,500 watts. Final one. A 500 Newton force is applied for 20 seconds by a machine with a power of 55 watts. What distance does it travel? First thing I need to know is power's work done divided by time. I rearrange that to become power times time equals work done. In that case, I can work out how much energy has been transferred. 55 times 20, 55 is the power, 20 is the time, gives me 1,100 joules of work done. So now I know the work done. I need to know, I know the work done. I can work out the distance it's travelled because work done is force times distance. In this case, work done is 1,100, force is 500. I rearrange my equation. Distance is work done divided by force. 1,100 over 500 give me a distance of 2.2 metres. A machine moves an object with a force of 500 newtons by 200 metres. It takes 2 hours to do this. What's the power of the machine? So again, work done is force times distance. I do 500 times 200, I get 100,000 joules. That's my work done. Power's work done over time. But the time I've been given here is in hours. It must be in seconds. So I need to convert that time first. Need to convert 2 hours into seconds. So in 1 hour, there's 60 minutes. In 2 hours, there's 120 minutes. In 1 minute, there's 60 seconds. So how many seconds in 2 hours? I'd do 120 times 60, giving me 7,200 seconds. I now know my work done, which is 100,000. I now know my time, which is 7,200. Divide those by each other and I get a power of 13.9 watts. Okay, if you pause the video and attempt these questions, if you are struggling with any of them, please whiz back the video and look at the steps I've done in order to calculate those. So pause that and attempt the questions. Okay, question 1. We should have an answer of 10 watts. Question 2. 1.66 watts. Question 3, 750 joules. Question 4, 2,000 watts. Question 5, 5.55 watts. And question 6, 2,400 joules. If you've got any of those wrong, please review the earlier part of the video and see where you may have gone wrong on your steps. Remember, there are 1,000 joules in a kilojoule, and you need to convert that back as well. Okay, which is most powerful on these? Pause the video and attempt this question. Crane A takes 20 seconds to move a 1,000 Newton weight 5 meters. Crane B takes 50 seconds to move a 500 Newton weight 30 meters. Pause the video and attempt that, and when you restart, I'll take you through the answer. Okay, so crane A. First I need to know the work done. Work done's force times distance. Force is 1,000, distance is 5, so it's 5,000 joules of work done. Power's work done divided by time, so that would be 5,000 joules is my work done, 20 seconds is my time, 5,000 divided by 20 gives me a power of 250 watts. Crane B would do the same thing. Work done's force times distance, but the force in this case is 500, distance is 30, that would be 15,000 joules, so much more energy. It takes 50 seconds to do that, so power's work done over time, so that's 15,000 divided by 50 gives me a power of 300 watts. So crane B is the most powerful, it transfers energy quicker. Okay, I hope that was useful. If there are any issues, please review the video. Thank you for watching, and best of luck. See you soon. Goodbye.